Okay, this is for Algebra 1. This is for, really, this says unit number. This is actually for our section 3-5. You need to know this information for our section 3-5. We're going to skip from 3-2 to 3-5. So we're talking about slope notes. This is going to be a review for some of you, but it's going to be brand new for some of you too. So you have this paper from the door, and I'm going to kind of jump around different things here. So the first of all, we want to talk about the rate of change, which we've already talked about before, but I just want to make sure that we define this so you completely understand what you're finding. So the rate of change, it's a ratio between a change in one variable relative to the corresponding, I'm going to go over here a little bit, corresponding change in another. So what we're talking about, it's a ratio between a change in one variable relative to the corresponding change in another. So what I mean by that is, I'm going to jump over here to the table, and what that means is like what we've been finding before. So we're going to be looking at the change in one variable to the corresponding change of the same over here on the y values. So this change from -4 to positive or -2, that's going up 2. This is going up 2. This is going up 2. So the change in one variable relative to the corresponding change in another. So -2 to -1, that's going up 1. -1 to 0, that's going up 1. 0 to 1, that's going up 1. So this means the change, the ratio. So a ratio, we talked about 3 ways to write a ratio. You've known that for probably 6th, 7th grade. But the one ratio that we're going to focus on is the slope. Okay? So the slope, the fraction. So the fraction form of the ratio that we're going to be talking about. So we're going to do the change of y over the change of x. So I'm going to show you a symbol that you may or may not know, but this is called delta, and that means the change of y over the change of x. So this means the change of. So that symbol, so we don't have to write the change of, they created this symbol to mean the change of y over the change of x. So the change of y, well, the y's are going up by 1 as the x increases by 2. So then we call this the slope. So our big idea is finding the slope in a table, graph, equation form by 2 points. So we're going to go through all of this. All right, so here, 7 to 11, that's adding 4. 11 to 15, that's adding 4. 15 to 19, that's adding 4. This one, 0 to -3, that's subtracting 3, going down 3, going down 3. So again, the change of y over the change of x. So change of y over the change of x. Notice this is a negative. So that's going to make that whole thing a -3 over 4. So it's really making the entire fraction. If one of them is negative, it's making the whole thing fraction, or negative. Now, if both of them are negative, if that's a -3 and a -4, it would be a +3/4. Okay? So your table, you're looking for a constant rate of change in the x and y values. Again, this is the addition or subtraction. It's either adding or subtracting for that change. Okay, so this is your change of y over your change of x. Okay, that's the ratio that we're talking about. That's the ratio. So when we talk about here, I'm going to bring this down here to this ratio. And in slope, we use the letter M to represent slope. Now, if you do a quick Google search, it's kind of fun. Why? Because I'm always those why people. Why do we choose M for slope? If you look it up, everyone who's taking French, this is going to be of interest to you. So look up that French word. And in fact, look up that French word, and why don't you put it right here? Put that French word right here on what they think. They're not for sure if it's really credited that word or not, but write that word there of the French word that why they chose m for slope. Okay, so the ratio again is the change of y over the change of x. What that means again is the change in y over the change in x. Okay, that's what we call slope. That constant rate of change is now going to be called slope. Now the m, when we were talking about a graph, that m, the slope of a graph, and somebody said this the other day, they were talking about the rise, oh I remember who it was, rise over run, okay, which means it's the vertical change over the horizontal change. Oops, I think I spelled it wrong. I did. Sorry. The horizontal change. So we'll practice that from a graph on finding the slope from a graph. You found from the table. Let's do it now between 2 points. So let's say our points that were given are 0, 4 and 6, 12. Well, what I want to do is look at these 2 points. If you're given 2 points, you can find the slope from these 2 points. Think of this as your x sub 1 and y sub 1. What that means is just the first ordered pair. So we do an x and then we do a sub 1 and a y sub 1. And then this is our second order pair. So we're going to put x sub 2 and y sub 2. And what we're looking for is the change in y over the change of x. So what we're looking here is this change of y over the change of x. Now the slope formula that they use is written like this. To find your slope, you can take the change of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the slope formula to use these 2 points. And there's a couple other ways I can show you too, but this really works with integers, so you have to be careful. So we're taking the change of y, so we're doing y sub 2, our second point, 12 minus 4 over 6 minus 0. And 12 minus 4 is 8. 6 minus 0 is 6. Now here's the deal with slope. Do not change this to an improper or mixed number, because the whole thing with slope, it's a ratio. But you do need to simplify it, meaning if there's a number that goes into both of these, the greatest common factor, go ahead and divide that out. So 8 and 6 are both even, so we know that we could divide both of those by 2. So the slope of these 2 points, that slope is going to be 4/3. Okay? So always simplify. Don't change it to a mixed number though. Okay, so let's try one more. Let's try -2, 7 and 2, -1. Because when the negatives come in, people tend to make some errors, so we have to be careful. Now what we're going to do here, I'm going to use this for some room here. But our change of y, so if it helps you to do x sub 1, y sub 1, x sub 2, y sub 2, that's fine. So we're going to take our y sub 2, so our change in y, so -1, that's our number, minus 7, okay, over 2 minus a -2, because our -2 is our x value. Make sure that you don't make an error here. This is where people make their errors. Now -1 minus 7 is a -8. 2 minus a -2 is a +4. Now you can simplify this. -8 divided by +4 comes down to -2, excuse me. So your slope of those 2 points, that change, it's really saying a -2 over 1, but if it's ever over 1, simplify it down to a -2. So if they ever give you the slope as a -2, just know it's a -2 over 1. This is meaning that for every time the x increases by 1, the y is decreasing by 2. What this means is every time the x increases by 3, the y is increasing by 4. What this means here is that every time the x is increasing by 4, the y is decreasing by 3. Okay, so it's meaning it's a negative slope. Okay, so now let's look at an equation. We are going to work with the equation some more, but the equation, now this is going to be in slope intercept form. Slope-intercept form. So slope-intercept form is written this way. We have y equals mx plus b. And the y equals mx plus b, this is your slope, and this is your y-intercept. In section 3.5, we're going to work with the slope-intercept form quite a bit. You're going to see two other forms that we're going to work with, but for this 3.5, we're going to work with slope-intercept form. Okay. So for example, if we had y equals 1/2 x plus 3, this is your constant. It's a constant number. That means, like, if, I don't know, I charge $3. Oh, no, that's not even a good example. Forget it. And then this is your slope. That's your slope. That is the change of as x increases by 2, y is increasing by 1. Okay? Okay, now down here, we have directness and steepness. Now direction. So your direction, you could have 4 different types of slopes. So we're going to talk about direction and steepness, and then it's going to go right down here also. So the direction here, if it's going from left to right, this is always going left to right. So if it's going from left to right and it's going upwards, this is increasing. So as x value increases, so does the y. If it's going from left to right and it looks like it's decreasing, that means as the x gets greater, the y gets lower. Okay. Horizontal. So we can do a horizontal slope. That means as the x is increasing, the y stays the same. Your y values are staying the same. And then we have vertical. Now these are types of slope. This is not a function, but we're just talking about types of slope. So we have vertical. Okay, so there's different directions, 4 different directions. And you're going to watch a video that's kind of annoying, but it's actually, you'll remember it. So now steepness. The steepness of the line, we'll look at how the slope and the fraction of the slope affects this. This is not too steep, so not too steep. It's not jumping up really high, really fast. This is a little steeper. So that's steeper. And then this is real steep. Like it goes up. Whoops. It's steeper than it was. But that's, very steep. And we'll work with the steepness of it. Okay. I'm going to stop this. I'm going to do a second video down here because I'm going to run out of time.